Hello, welcome back. Today we're going to be finding the areas of regular polygons. The objective is you can find the area of a regular polygon by finding the area of a triangle. Now that sounds a little weird, but by the end of this video, just finding the area of a triangle will allow you to find the area of a regular polygon. So for some vocabulary, we've got a regular polygon is a shape with 3 or more sides. The side lengths and angle measures are all the same. That's what makes it regular. Example, a square is a regular polygon because it has 3 or more sides, and all the sides are the same length, and all the angles are the same. In other words, 90 degrees in this case. So what we're going to do is we're going to find the area of a regular polygon by finding the area of a triangle inside the polygon first. Now we're going to go ahead and look at a regular polygon. In this case I've got a pentagon, and we're going to cut the pentagon into 5 different triangles. Notice these lines that connect into the center create 5 different triangles. And the reason that works is because there's 5 different sides or 5 vertices to draw the lines into. All I want you to get from this is if you have a regular polygon such as a pentagon, the number of triangles inside of it is the same as the number of sides. Now we can find the area of the pentagon by finding the area of one of those triangles, any one of those 5 triangles we can find the area of, and then multiplying by 5. As a reminder, the area of a triangle is base times height divided by 2. And what we're going to do is we're going to find the polygon area. Polygon just means many sides. By finding the area of a triangle inside of the polygon and multiplying it by the number of sides, because that's going to be the same as the number of triangles. So what we're going to need to find is we're going to need to find the base and the height of any one of the triangles inside of that polygon. So we're going to find the area of the polygon below. We're going to need to, in order to find the area of the polygon, use our area of the triangle first. Let me outline the triangle in red that we're going to find. We're going to find the area of this triangle and then multiply by 5 because there's 5 sides or 5 triangles in total. So the first thing we need to do is to find the base and the height. Now you notice from the top of the triangle down to the bottom there should be a right angle here letting you know that's the distance, is our height. Across the bottom is going to be our base. So we can find the area of one of the triangles. I'm going to do A for area and then a small triangle underneath to let me know and let you know that I'm finding the area of the triangle is equal to base times height divided by 2. So the area of my triangle is going to be the base, 5.1, times the height, 3.5, divided by 2. When we grab our calculator and we go 5.1 times 3.5 divided by 2, we get 8.93. So the area of just one triangle is equal to 8.93, or 8.925 exactly, centimeters squared. Now we don't want just the area of one triangle, because that would give us just this part of the entire polygon. We want the whole thing. So we need to multiply that by 5 since there are 5 triangles altogether, or 5 sides. So to find our final answer, we're going to go 8.93 and we're going to multiply by 5. So we grab our calculator and we go 8.93 times 5, press enter, and we get 44.65 as our final answer. So the area of the polygon is equal to 44.65 centimeters squared. But what if you're given the following polygon and we're asked to find the area of it? And all we're given is this 3 centimeter measure right here. Well, we can mark off a triangle and we can immediately see that the other measurement is 3 centimeters. But again, that's not really helpful because we have to have the height and the base. Let me show you what happens when I draw the height of that triangle. When I draw the height of our triangle, it creates a right angle right here, and you'll notice what you have is the hypotenuse of a right triangle. Well, the good news is we can find the angle of our triangle, this angle right here, and then we can find the height using sine, cosine, or tangent. We can also find the base using sine, cosine, or tangent as well, or you'll find out later, we can use the Pythagorean theorem. So how exactly are we going to find the angle of that right triangle? Well, I've written down a formula for you. This formula won't be provided to you, so you're going to have to somehow memorize it. Now, an easy way to remember it is that all of the angles inside of our polygon are going to add up to 360 degrees in total. So all the interior angles add up to 360 degrees. Well, if I've got 5 triangles, 1, 2, 3, 4, and this big one, 5, not the one split in half, that means that if I take 360 divided by 5, I'll get the angle, just one angle measure, let me mark that in green, of each of the triangles. But we don't really want the whole angle measure, we want half of it. So what we're going to do is we're going to go 360 over 2 times the number of sides. 2n, we could say. What that does is it gives us half of the angle measure, let me mark that in red, which is what we're looking for. Half the angle measure of any one of those tops of the triangles. So again, to find the angle, all you really need to use this formula right here. So let's go ahead and find that angle measure. I'm going to go 360 over twice the number, 2 times the number of sides. Notice I've got 1, 2, 3, 4, and this whole thing right here, even though it doesn't look like it, is one side. So we've got 2 times 5, which gives us 360 over 10. You always need to multiply your bottoms first before you can divide, giving us 36 degrees. That really doesn't look like a degree symbol. 36 degrees in total. That means this angle right here is 36 degrees. So now I've written the degree measure and we know the hypotenuse of our triangle. How are we going to find the height using sine, cosine, or tangent? Well, I look at it, again, I'm given the hypotenuse because that's across from the 90. This is the hypotenuse. And I want the height. Now the height is adjacent to our 36 degrees. So I have the adjacent, or rather I'm looking for the adjacent and I want the hypotenuse. Which one, sine, cosine, or tangent uses adjacent and hypotenuse? If it's helpful, you can write the acronym SOHCAHTOA. And you'll notice A and H show up in cosine. So we're going to take cosine of our angle, 36 degrees, is equal to the adjacent, which we don't know, that's our height. Let me use H for that, over our hypotenuse, which is 3. So I can make a proportion, and I can cross multiply to solve. Cosine 36 times 3 divided by 1 should give us our height. Go ahead and grab your calculator, turn it on, make sure it's in degree mode. By going mode and then over to degree, press enter. And we're going to go cosine 36 times, what was that measure, times 3 divided by 1. And we get 2.43 as our height. So we found our height to be 2.43, and that leaves us with just having to find the base somehow. Now we can't find the whole base, but we can find part of it if we choose using the Pythagorean theorem. We can do a squared plus b squared equals c squared. This being a, this being b, and this being c. So 2.43 squared plus, we don't know what, b squared is equal to 3 squared. We're going to subtract 2.43 squared from both sides. giving us, so 3 squared minus 2.43 squared gives us 3.1. So far we know b squared is equal to 3.1. To get the b by itself, we take the square root of both sides. So we go second square root, 3.0951. I'm going to use an exact answer, which gives us 1.76. This means that our base, this b right here, and it's not the entire base, it's half our base, is 1.759 or 1.76. Which means if we multiply by 2 to give us the entire base, we can now solve for the area of the triangle. So 1.76 times 2 gives us the area, or rather distance, of our base right here. This is 3.52 roughly. The height was 2.43. And now that we've done that, we can solve for the area of the triangle. We can now finally solve for the area of our triangle and then our area of the entire polygon. To find the area of the triangle, we're going to go 2.43 times 3.52, and we're going to divide by 2. So, grab our calculator again. 2.43 times 3.52 divided by 2 gives us 4.28. Now, that is for just one area of one triangle. That would be just this area right here. We would then have to multiply that by 5 since there are 5 sides in our polygon, giving us finally, in the end, our area to be 21.38. I've got one for you to try. Go ahead and see if you can find the area of the following regular polygon. Pause the video, work it out, and press play when you're ready to see the answer. So, just like in the previous example, our first goal is to find the base and the height. Now, we need to find this degree measure right here, and to do that, we're going to use our formula for finding the degree measure, which is the number of our 360 over 2 times the number of sides. Now we've got 1, 2, 3, 4, 5, 6, 7 sides. So we're going to get 360 over 14 as our degree measure in this case. So we get 360 divided by 14. Gives us 25.71. And so our degree measure right here is going to be 25.71 degrees. Now that's the angle measure of this angle right here in our triangle. Now we've got the angle measure. We can go ahead and find our base and our height using SOHCAHTOA. Now to find the height, you'll notice that we're looking for the adjacent, since the height is adjacent to 25.71, and we have the hypotenuse. So we're going to use cosine 25.71 is equal to the adjacent over the hypotenuse. So I'm going to say x, or the h if you want to call it the h, over 9. We're going to cross multiply. We get 9 times cosine 25.71. And we're going to divide by 1, which is the same thing as just the original answer. So we get 8.11 as our height. Now that we know the height, we can go ahead and find the base, or rather half of the base, because really we're looking for the base of the entire triangle, not just this half right here, by doing a squared plus b squared equals c squared, or you can use SOHCAHTOA again. I'm going to use a squared plus b squared equals c squared. So we get 8.11 squared plus, we don't know what b squared is, equal to 9 squared. So I'm going to get 9 squared minus 8.11 squared, and I'm going to take the square root of it. So 9 squared minus 8.11 squared, and then take the square root. 15.2279. Give me 3.9 as my base. So half my base is 3.9, which means my entire base is 3.9 times 2, which is the same thing as 7.8. Now all that was to just get the base and the height, 8.11 and 7.8. So this 8.11 and this 7.8. We can use that now to find the area of our triangle. So the area of our triangle is going to be 7.8 times 8.11 divided by 2. And that's the area, again, of just that one triangle right here. So we get 8.11 times 7.8 divided by 2 gives us 31.63, or 629. If we multiply that by the number of sides, since there were 7 sides, that'll give us the total area since there were 7 triangles, or 7 sides. So our area of this particular polygon should be 221.4 units squared. I say unit squared because we don't actually know what the units are in this case. We just use the word unit as a placeholder. This one's a tiny bit different. Still basically the same concepts, but notice you're given the height and not the hypotenuse. So what we're going to have to do is we're going to have to solve for just the base. We really don't need the hypotenuse in this case. We can find the base fairly easily just using SOHCAHTOA. So you can find the base on your own, then find the area of the polygon, and pressing pause and press play when you're ready to see the answer. Just like before, I'm going to give myself a right triangle right here. I need to find the degree measure, so I go 360 divided by 8 times 2, which is the same thing as 360 divided by 16. Which, when we put in the calculator, gives us 22.5 degrees. Now, we're going to use SOHCAHTOA in order to find the missing length we have. We already have the height, so we're not going to use SOHCAHTOA to find it, but we can use SOHCAHTOA to find this half of our base length right here. And what we're going to do that is we notice that we have the opposite of our angle. So this right here is the opposite, and next to it is 3.7, which is the adjacent. Which trig uses, or which one of sine, cosine, and tangent uses opposite and adjacent? The answer is tangent. So we go tangent of our angle, tangent of 22.5 is equal to, notice it's TOA, so it's opposite, which we do not know, so I'm going to use an x, over the adjacent, which we know, which is 3.7. I'm going to go ahead and cross multiply 3.7 times tan 22.5 and divide by 1. Which, when I put it in my calculator, I got x, or that missing length right here, as 1.53. Now remember, that's just half of our entire base length, so we're going to multiply that by 2, giving us 3.06 or 3.07 in total. So we have our base is 3.06, our height is 3.7. We can actually now solve fairly easily for the area of our triangle just by finding base times height, 3.7 times 3.06 dividing by 2. That's going to give us the area of one of our triangles, which when we put in our calculator gives us 5.66, and that means the area of our polygon is going to be equal to 5.66 times the number of sides, which is the number of triangles. So times, there were 8 sides, 1, 2, 3, 4, 5, 6, 7, 8, times 8 gives us in the end 45.29 units squared.